does the stack system architecture look like? And it took forever because I was trying to draw it all. Now I think I have slides. I think it'll go a lot faster. And this is kind of typical for most websites. And there's variations, but most websites have a general architecture like this. And I'm going to start very small and build out. So first, okay. So how does a website work in general? Well, you're at your web browser, you're at Chrome or whatever, and you type stackoverflow.com. It sends the request, and there's some web server. Maybe it's running on a big Dell server someplace or a virtual machine in the cloud, and it generates a bunch of HTML, which it then transmits back to the web browser, which displays it as a web page, right? So that's basic web server 101. Now the problem with this is that there's only one server. So if we need to upgrade the software, we have to take down the website to upgrade the software, because you can't run a website while it's running, right? Like if you've when Windows updates runs, you have to reboot. And if you've noticed at Stack Overflow, we never put out a notice the site's down because we're upgrading our software, and yet we push new versions of software multiple times a day. It's hundreds of times a month. So, well, how do we make that work? Well, what the architecture really looks like is your web browser thinks it's talking to a web server, but it's actually talking to a load balancer, which is a bit of software that collects the request, sends it to, we have 9 different servers. The load balancer sends 1/9 of all the requests to any given machine, which does what I said before, generates the HTML, sends it back. So the load balancer lets us pretend that these 9 machines are one. And so this has a couple benefits. First of all, we can, if we need to upgrade the software, how do we do it? Well, we tell the load balancer, stop sending any new traffic to this machine. We upgrade it, make sure it's fine. Then we do the next machine, on and on and on. And that's called a rolling upgrade. And it's all automated. I don't have to think about it. Actually, developers, every time they commit a change, there's a control panel. They can press a button and push. They have total authority to push new software to the website. Okay, so so one benefit is rolling upgrades. Another benefit is if this machine just dies. I mean, hardware has problems occasionally. If a machine dies, the load balancer detects that, immediately stops sending information. You could buy the best hardware in the world. It's going to crash sometime or have some kind of need to reboot. So the load balancer gives us scalability. Oh, right, and we could add more. If we knew, every couple years we add more web servers so that we can handle more traffic. Improves survivability, which is what I mentioned before with failed hardware, and it lets us upgrade the site without taking it down. So actually, just building up, the architecture is a little more complicated. We need to upgrade the software of the load balancer, right? So there can't only be one. That would be a single point of failure. So we actually have 2 load balancers. One is in use at any given time, and we can fail over between the 2 to do software upgrades. And then we also have all of our data is stored in a database. The database is kind of slow, so we actually have a cache. So we always send a query to the cache. Like if we're looking up someone's profile, first we ask the cache, do you have that person's profile in your memory? And if it says no, then we hit the database. But there's a probably 80% chance that it's in the cache. So we would need a database server that's probably 10 times more powerful if we didn't have the cache. There's other services that provide our search box and other services like generating email, which you'd think is really simple, but it's actually super complicated. So we have a separate services that generate the emails that we send out. So how does a query really work? It goes from your web browser, hits a load balancer, which picks one machine. These machines have no data on them. I mean, they have the software, but they don't hold any data that changes. The 50 million questions and answers that are on Stack Overflow are all on the database. So it gets the request and it farms out, if it needs to talk to a service or the database or the cache or Elasticsearch. It sends those requests out in parallel if possible, gets back all the data, puts it into a web page, and sends the web page out.
So databases are searchable inherently. What's Elasticsearch doing?
Oh, so why do we have Elasticsearch if we have a database which is searchable? Elasticsearch is, you're right, it's a copy of the database, but Elasticsearch has, it's more flexible in its search, so it can handle, like with SQL Server, you have to know what you're searching for. You might search for things that are tagged Python that, but you can't say that mention iterators, right? Elasticsearch provides what they call full text search, and there's also some security related things that are kind of weird to explain. Okay, so I've mentioned the need for no single point of failure before. So we actually take that to another level because, as I mentioned in the talk earlier, we have the Colorado data center, which is a clone of the New York data center. It's not an exact copy. It's actually less powerful. Here we have a huge amount of spare capacity. When we fail over to Colorado, we're running a little close to the edge. We have less spare capacity. And the website might be a little bit slower when we're running out of Colorado, but that's because we have fewer web servers. They might be older machines, less powerful, but you probably won't notice the 1 week every 6 months that we've failed over. And certainly failing over to a slower data center is better than failing over, not being able to fail over at all, or having to spend a lot of money on fancy hardware. So that's in a nutshell the architecture. Any questions? Yes.
So is all the HTML, JavaScript, that sort of thing generated once, or is it continually fetching?
Oh, good question. So is all the HTML generated once? It's a mix. There's, as much as possible, if something doesn't have to change, we keep it exactly the same, and then the caches very efficiently can deliver it to you. For when you view a question and answer page, that we're generating on demand because if you've ever sat and watched a page for a long time, if someone posts a new answer or a new comment, your page updates right then and there. And so there's a lot of dynamicness to that page.
So do you use sockets and that sort of thing?
Yes, we do.
I've done a project with live updates.
Mm-hmm.
It's fairly confusing because I couldn't use SQL databases. So I got told about Redis, whatever it's called.
Redis.
And that kind of just stopped there. So I'm not quite sure
Ah.
how Redis applies to sockets.
Oh, okay. So that's a whole nother thing. When you send your request, you're actually sending multiple requests because the page, first of all, comes back with just the HTML, and that might say, here's a bunch of images that need to be loaded. So there's more requests that are gathering those images to put the whole page together. And then if you look at the top of your page at Stack Overflow, there's a little indicator of notifications, which if you're just sitting at the page and a new notification comes in, it might change from 1 to 2 or 2 to 3. So the way we do that is the JavaScript that you've downloaded actually tells your browser to open a permanent connection to us. And that connection we use to push notifications to you to say, change that, the counter, the notifications counter. Or it might say, new answers have appeared, and we do some stuff in the background to kind of animate those new answers coming in. The reason you might have used Redis in that is, so we use Redis just for the caching feature, but Redis also has what they call a message bus, which is useful for doing those kind of dynamic updates.
So is that how you do it, or does that happen somewhere else where?
No, we do it totally differently. There's a lot of different ways to do it. Yeah. In back?
So I have two questions. First question is, why doesn't Stack Overflow use a cloud?
Why do we use our own data centers instead of moving to the cloud? Good question. When the company started, the cloud didn't exist. And we've designed things in a way that we didn't need to. It was cheaper to be in our own data center. But the cost of cloud computing is dropping and dropping. And we're now doing a big project to move to the cloud. So by this time next year, we'll probably be running out of either Azure, or Google Cloud, or Amazon.
And the second question is, why does Stack Overflow use, let's say, Windows instead of, let's say, Linux?
Good question. Why do we use Windows instead of Linux? So we're actually a mix of Windows and Linux. The reason we started with Windows is because the two people that founded the company were ex-Microsoft employees. And they know .NET very well. So this is Windows, and this is Windows, or Microsoft SQL Server. And then to get the Microsoft products are not known for scaling really well. They're not the fastest products in the world. So how do we get this to scale? We surround it by Linux for scaling. So Linux powers the Redis cache and search and the load balancers. So I like to say it's like that candy. It's a GUI Microsoft Center surrounded by a hard Linux shell. Or a Microsoft GUI surrounded by the Linux shell. Yes?
So how do you update the data in Elasticsearch? I mean, like how?
How do we update the search index? Every time.
Yeah, I think you don't want to store the exact same data in the database, right?
Right. So every time you post a new question, answer, comment, or tag, that is stored in the database, and then we also send a copy to Elasticsearch so that it can be in its corpus. Yeah. Which is actually, it's actually pretty cool that Elasticsearch can handle dynamic updates like that. When I was at Google in 2006, Google's equivalent of Elasticsearch couldn't handle dynamic updates. They were updating Google was basically the same site, the same search and search data for 20 days. Every 20 days, they would change to the new version of the database. And it was around 2007 or, yeah, I think around 2007 that they went to a more dynamic model. And it was a huge, huge effort. It's a whole different kind of computer science problem. Other questions?
I find in our attempts to automate here that we see something we're doing by hand, we automate it, and that reveals like the next layer of things we're doing by hand. And so we try to automate that, but that reveals the next layer. How's, in terms of updating this, how much do you still have by hand and how much have you got automated?
Good question. So software updates are fully automated. If there's a bug, rolling back is not automated. There's a lot of, like upgrading the load balancers and the Redis cache, that software is pretty manually updated because we don't do it too often. there's a trade-off. Like you want to automate everything, but if you do it once a year and it's going to take 2 months to automate, there's no payback. So we're always in this challenge of, what can we automate, but also what should we automate? Yeah, and actually, automating things, the benefit isn't. People think you automate things so that the process happens faster, but that's the least of my concern. I mostly automate stuff because it's error prone, and by automating it, instead of 10 manual steps, it's one button, or even if it's 2 steps that are manual, that's better than 10 manual steps. I'm more about reducing error-prone processes.
I find the hand processes you forget. When we needed the minus
Forget
M flag
them.
on this.
Right.
Remember last time we spent a week
Right.
finding the minus M flag?
Yeah, actually, an even better part of automation is once you've automated it, other people can do it. So even if you haven't fully automated it, but now it's like you have to run this shell script and then run this, I can delegate that to anyone else on the team instead of if it's 15 steps that only I understand. And so I do this process, and I'll send you a link you can send out to the class. I have an article about using documentation as your first step to automation. So we'll have a wiki that'll say, yeah, this process is 20 steps, and here's the 20 steps. And then someone will come along and say, well, the last time I did it, here's the actual command, and they'll edit the wiki to have the actual command. So now you're just cutting and pasting, and then someone will come along and say, well, I've improved this bit of code. It's doing no error checking. So now I've improved it, and then someone will come along and say, well, now we have a little bit of command line, cutting and pasting for 20 steps. I'm going to take those 20 parts, put it in one big script. And so maybe you didn't automate it fully, but you've gone, over the course of a year, you've gone from we don't know what we're doing to we know what we're doing to now we have little command snippets that help us to, maybe the first half is a shell script and the rest is manual, or now both halves are automated. And it's just this continual improvement. And it's really important to create a world where everyone on their team feels like empowered to edit that wiki or make improvements or turn it into a shell script. Because that's how things are just always getting better. Yeah, and that always has a return on investment. Documentation, it's easier to justify. I'm going to spend half a day documenting this process, where you might not be able to justify spending 2 months to fully automate it. And let me tell you, that might sound like insignificant, but you will be the hero. If you're the person on the team that takes what other people does and documents it into the wiki so that anyone can do it, you will be the hero. I've heard people say, well, if I document my job, won't they fire me because everyone can do that? It's the opposite. I've been a manager for, well, I've bounced between manager and non-manager for 30 years. And I've had to fire people. And I've been in situations where my boss's company said, we have had cost cutbacks where you have to pick one person to fire. They might be great, but you might have a team of all great people. You have to reduce your headcount by 1. And I look around, do I get rid of the person that writes great documentation? Hell no. They're worth like 3 people. So be that person. Because you're in the military, the term is you're a force multiplier. You're one person that is enabling everyone to be more efficient. So yeah, documentation is freaking awesome. Cool. Other questions? About anything in the world? Oh, wait, one last? Or, yeah. How do I what? How do you exit Vim? I'm old school. I do :WQ, but I also do Shift ZZ. Yeah. You know how you can tell if someone uses VI in like their Word documents. You'll see :WQ. Do you know how you can tell if someone uses Emacs? Oh, don't worry, they'll tell you. Yes.
So do you do a lot of Windows PC, Mac, or Linux?
I'm my laptop's a Mac, and but I'm usually pushing code usually to Linux stuff, some Windows stuff. Yeah. Is that what you were asking, or?
That.
Oh, okay, cool. Yes.
Like DDoS attacks on the website?
Yes. Yes, for no reason at all. People love to attack our website, and we have a lot of different mitigation techniques. Yeah, one of the simplest things that we've done is they'll be attacking us at one particular IP address, and we change our IP address, and they don't follow us to the new one, and we see that they're still attacking the old address, and like 2 weeks later, they're still attacking it. Yeah, so they're not always super smart, but it happens. If you watch the first episode of Mr. Robot, where they're under a DDoS attack, and the manager leans over and says, "Have you changed the DNS?" and it looks really fake in Hollywood, that was actually accurate. That's totally like we changed the IP address in DNS. And yeah, so. Are those hands up or just waving? Okay, cool. Well, thank you all for coming. I hope you all have awesome careers in this field. Thank you.